All right, so this is, I'm gonna do about 5 or 6 practice problems, putting quadratics into graphing form. Honestly, it's easier to graph them first and then write the graphing form. But as far as standardized tests and what you might be expected to do in your next class, we'll put it in graphing form. All right, the first thing is the A term is given. So you can always do that right from the get-go. And then we're either gonna have a plus or a minus, and all we need is the vertex. And the vertex, the way that I think most people find the easiest thing to understand. Not necessarily the quickest way to do this, but the one over the years that I've seen has been most successful is to simply find the x value of the vertex by using minus b over 2a. All right, so we have ax squared plus bx plus c. Obviously, b is minus 20. So the opposite of minus 20 is positive 20. Right? And 2 times a is 2. 2 times 2 is 4. So we now know that our value is 5. I wish I put that slightly in a different place because I'll move this over and move this here. So 5 is our key x value. And from the lectures, we know that there's a minimum. If you have a positive a term, you have a cup shape up, and the minimum occurs at 5. But the minimum of x squared is 0. You cannot square a number and get a smaller answer than 0. So therefore, 5 is acting like a 0. So when I put 5 in to make it act like a 0, I write minus 5. And now we can get whatever y value comes out from the original equation, because we have a formula here for finding y values if we have a number. Now, if I put 5 into the middle term, I get minus 100. Without looking at the first term, if this is the right answer, I will get half of this and the opposite sign. So if this is negative, I'm going to get a positive 50. And you can put 5 in to see that that is true. I'll make sure you can see it's true. You square before you multiply. 5 squared is 25 times 2 is 50. And then we add 5 here. Now, when you add these two terms, you either get the opposite of the first term or half of the second term. I prefer to divide the second by 2 and add 5, and that tells me that minus 45 is my y value. And I can write that minus 45 here. It is also given that if you plug a 0 in, these are products. If you plug a 0 in, you get 5. And 0 is to the left of 5. And I don't like two numbers showing up twice, but it is what it is. It's the first one I put down there. We're going to do 1, 2, 3, 4 more. Now, I knew the y-intercept was on the decreasing side, which means the middle term must have had a negative coefficient. Oh, yes, it did. And I will show you why I know that at some point in the near future. All right? And if you square the change from 5 to 0, you get 25. And how far is it from negative 45 to 5? 50 units. Oh, that's where this number 2 is coming from. All right, let's go and do another one. See how you do. All right. I'll take the gift. I'll do minus b over 2a, which is minus 12 over 2 times 3, and 6 goes into negative 12. Minus 2, I want that number to act like a 0, so I say plus 2. Not doing anything different with this parentheses than we did with the equation of a line. And then, of course, I have squaring. And if I put negative 2 into the equation, I get 4 times 3, 12, which means that's got to be minus 24, or I got the wrong number. Oh, minus 2 times 12, minus 24, minus 7. I'll cut that in half. minus 12, minus 7, minus 19. Minus 19. That's my vertex. Which means that I have minus 2, minus 19. That means my y-intercept is on the increasing side, which means my linear coefficient is positive. Oh, yes, it's positive. And if I put a 0 in, I get minus 7. How far is it from negative 19 to minus 7? 12 units. I should put some arrows here. And how far is it from negative 2 to 0? Negative 2 to 0 is 2 units of change, but I'm looking for quadratic change, which is 4 units. What is 12 divided by 4? The tripling process of the squaring process as measured from the vertex. That's how that function works. And we're going to learn in future classes that if you can see the graph, you know the roots in 10 seconds or less. Imagine that, being able to find when this thing equals 0. We'll do that pretty soon, but not for your scrimmage tomorrow. That'll be on your next test. All right, we got another one here. Minus 2x squared. So now I know I have a parabola that's going down. I know I'm in the increasing side, 0, 9. It's going up. We read graphs from left to right, so you follow your finger to the right, increasing, decreasing. That plus sign, I'm on the increasing side. But let's not know that. Let's go and do it out. All right, let's do it out. So we can take, that gets me the first term. That's the same as that. And now I got to do minus b over 2 times negative 2. That looks like a positive 4 to me. So I better write x minus 4, so that acts like a 0. What I like to do, no, I'm going to stick with what we're doing. All right. So there's faster ways to do this. All right, so I'm going to put 4 in. That's 64. This better be minus 32. Oh, yeah, 16 times negative 2. Yep. And when I add negative 32 and 64, I actually get 32. Right? That's bigger than that. So I get 32 plus 9, 41. Cup shape down. That's what I know now. 441. 0 is to the left of 4. And the squared change from 4 to 0 is 16. But I know I'm going to go to 0, 0, 9. How do you get from 41 to 9? You got down 32. And what's minus 32? Right? If I went over 4 units, I should actually go up 16. But if I multiply that square change by negative 2, I actually go down 32 units. Oh, take 32 away from 41. Yeah, that's nailing it. Let's do another one. I hope you get it right tomorrow. Another cup shape down. What's the x value of the vertex? Minus b over 2a minus 1. So I write negative 5 times x plus 1 squared. If I put negative 1 in, that's negative 5. Negative times a negative is positive 10. Oh, there's that 2 to 1 again. Plus 4 is the same as 5 plus 4, which is 9. Oh, okay. We're done. That's the graph. Be nice to know where 0 was. It looks like it's on the decreasing side. Oh, yeah, that is a minus 0, 4. Moving on. Maybe I should tell you that the range of this is y values less than or equal to 9. All these y values, you know where they are? Smaller than that one. Below it. All right, so here's one with a coefficient that doesn't immediately show itself to you. But I hope you know that it's a 1. So minus b, 10 divided by 2 times 1. Looks like we got a 5. So that must mean that. And I guess I don't need a number here. So I guess if I put a 5 in, I know if I put a 0 in, I want a 9. Right now, if I put a 0 in, I got 25, so I know it's gonna become minus 16, but let's see another way to do it. Let's put 1 in here. I'm sorry, what was the number 5? Let's put 5 in here, minus 50. I'm hoping that's 25. Oh yeah, minus 5 squared, yep, negative times a negative positive. Plus 9 is minus 25 plus 9. Oh yeah, it's minus 16, so there's the graph. Positive cup shape, 5 comma 16. 0 is on the decreasing side. Oh yes, that's negative. So 0 gets me negative 16. And I guess that's that. And I have given you a special case, right? Because this one here doesn't seem to have a middle term, a linear middle term. But it's already a perfect square. There's the squaring process, just like this one over here had a squaring process. Okay, so x squared is simply going from 0. Right, so what is 2x squared plus 10? It's really 2 times x minus 0 squared plus 10. So I'm centered on the y-axis. I'm 10 units up, 0, 10. And it would be nice if we actually had some other point here. Doesn't matter what you plug in. If that's 10, I think I better go with 1. So 2 plus 10 is 12. So I think I got to put 1 and 12. I suppose I could get away with a 2. 2 is probably there. Actually, 2 is 18, isn't it? 2 squared, 4 times 2, 18. So it's a little higher. So I kind of got myself bunched there. Can you write this equation? Pause the video and try. X minus 2 squared plus 67. We got that part. Quadratic change from 2 to 0 is 4 units, right? 0 to 2. We're looking at the squared area. That's 4. I don't want 4 units because 4 units going over and up 4 certainly isn't taking me to 3. How do you get from 67 to 3? You better go down 64 units. And so that becomes minus 16, x minus 2 squared plus 67. And this becomes minus 16x squared plus 64x plus 3. And if you tab the time, you're going to have to learn to expand those. So you should work with that until you get that. And this we talked about early on, day 1 or day 2, about kicking a ball 3 feet high, 64 feet. Nice force on that ball. Gravity brings it back to Earth. So these numbers actually start to have some meaning out there in the real world. In fact, that's what we use math for, to study relationships that are out there. But we're studying them in here. All right. Those are 2 problems you're going to see on your scrimmage tomorrow. If you do the 5, you got a better chance of getting the ones tomorrow right.